Show that the function fz equal to sin x cos hyperbolic y plus iota cos x sin hyperbolic y is continuous and also analytic everywhere. Now here, what is fz? It is u plus iota v. So equating this to the right hand side, equating the real and imaginary parts, we get u to be equal to sin x cos hyperbolic y and v to be equal to cos of x sin hyperbolic y. Now here u and v are continuous everywhere. Why? Because all the polynomials, please remember this, all the polynomials and the sine, cosine functions, trigonometric functions, all these are always continuous everywhere. And here u and v are the trigonometric functions, so these are continuous everywhere. So let's write this. Since u and v are continuous everywhere, so therefore this fz function is also continuous everywhere, because fz is u plus iota v. So we are writing that fz is also continuous everywhere, and our first part is done. We have shown that the given function is continuous everywhere. This is the first part. And now we need to show that the function is analytic. So for that, CR equations should be satisfied. So first, let's write back the functions u and v. So the u is sin x cos hyperbolic y and v is cos x sin hyperbolic y. And what are the CR equations? It is partial derivative of u with respect to x should be equal to partial derivative of v with respect to y, and partial derivative of u with respect to y should be equal to negative of partial derivative of v with respect to x. These are the CR equations. Let's check this. The partial derivative of u with respect to x is what from here? Derivating this with respect to x, we get cos of x cos hyperbolic y. And the partial derivative of u with respect to y is what? It is sin x into sin hyperbolic y. Similarly, the partial derivative of v with respect to x is what? From here it is negative sin x sin hyperbolic y, and partial derivative of v with respect to y is cos x cos hyperbolic y. Very fine. Now let's check. The partial derivative of u with respect to x is equal to partial derivative of v with respect to y. Yes, these both are equal, so first equation is satisfied. And also the partial derivative of u with respect to y is equal to negative of partial derivative of v with respect to x. So the second equation is also satisfied. And these equations are satisfied for all the values, right, of x and y, whatever you put. So here the cauchy-riemann equations are completely satisfied. And since all the partial derivatives of u and v with respect to x and y are continuous everywhere, since these are all trigonometric functions, so these are continuous everywhere, and also the cauchy-riemann equations are satisfied. So from this we say that the function is analytic everywhere. So let's write this. Since the four partial derivatives are continuous everywhere and CR equations, that are the cauchy-riemann equations, are also satisfied, it is very important that these derivatives are continuous everywhere. It is important. And CR equations are also satisfied. So we say that therefore fz is analytic everywhere. Okay, thank you.